let's see. Whoa, Jeff. This is it, yeah. All right. Ooh, I just so love this problem. I mean, all right, just look at this. What method would you use if there's a x squared inside of another function and there's an x outside? What method do I use to integrate? How would you integrate? Come here. Sure. How would you integrate x square root of x squared minus 2 dx? U sub. Does it really matter what function this is? No. So that's what this problem is saying. Look, I got x squared inside, I got x outside. U sub. Yeah, and then change the limits, and of course, then that first piece of information is crazy important. Okay. I like it. Anything else? Anything else? You guys good otherwise? All right. You're all like, let this week end, Jeff. All right. We will in a bit. So, last time we finished the worksheet that I just had here somewhere, but it was about shells. On one side was washer and disc kind of practice, setting up the area we were looking at. And the other side was talking about shells. And I just had it, and of course, oh, there it is. Okay. So remember this. So we had this side, this beautiful. Oh, look at that. It's just beautiful. And then we had this side. We did all these, and that was the last one we did, and blah, blah, blah. So it was all about just not even evaluating. Well, I guess we did. We evaluated the integrals, but mostly the purpose of this was, how do I get myself a rough sketch so I can identify the parts that I need? Right? Now we're going to transition into, let's look at shell method. Let's look at the reasoning behind why I would use one method over the other one. So that's where we're going to transition to. So any questions on that? Well, that's the one we did last time. There's the, well, shit. Anybody need that handout? There it is. Look at all that work we did. Look at all the colors I used. My God. Okay. I guess not. So, let me give you the next stage.
Sorry.
What's up? Think about it.
Oh, are you gonna tell us on problems what method to use, or do we have to? Yes.
Mostly no.
Mostly you're not gonna tell us?
Mostly I'm not going to tell you, because part of this is figuring out which method to use when. That's part of what I have to test you on. A whole week is not enough. People had to add one more day. Whatever. All right. Should I even record this? Sure, I'll record. So look at this beautiful thing. All right. The reason the function is a little bit, it's a little bit worse, right? There's some decimals in there, but they cannot scare us. Don't let them, please. Who gives a shit? Is because I stole this image from the book, and then I created a function that roughly looks like that, right? All right, so it has to be this precise to end up kind of looking similar. This is what it actually looks like. It's pretty close. Okay, so can you guys just take a minute, try to set up what the integral would look like if I was going to use discs to figure this out? And of course, just to remind you, what's the most important first step? I think you got it. Yeah, exactly. Is it going to be integral dx or integral dy? Because that's going to set up everything else you do after that. Well, okay. Give it away.
Oh, sorry.
It's all right. Oh, sorry, buddy. Thank you. Sure. Yeah. I was just saying.
I've done this before.
Okay.
I just don't even remember how.
Oh, you didn't get. Well, you should have said something. Do you need this handout or no? No, you got this handout, right?
I think I did.
That
Yes, I did get that.
Okay. That partially explains it. You just weren't here when we were doing all these
No.
examples. Okay, that's a good video to
I
watch.
watched the lecture though.
Okay. Let me catch up to you guys. So, of course, this is going to be, if I want to try to use discs, this has to be integral dy. Because I'm rotating around not just something parallel to the y-axis, but the freaking y-axis, right? So that means something immediate. But let me pretend like I'm not even going to think about it yet. Wouldn't I need like a, how many radii would I need? 2, right? Isn't the middle going to be empty? So isn't there, if I go from the axis of rotation out, I hit the first wall, and then hit the second wall, and even worse, there's kind of like a third freaking wall here. All right, so I just want to point out how much is bad with trying to use discs here. I don't know if you guys really understand. Doesn't everything fundamentally change right here? Isn't there one function governing this wall up to here, and then there's a new function there? You guys understand what I'm saying? We saw this once before with the shape that I didn't mean ahead of time to make it that difficult, where I had to do 2 integrals because it kind of changed at one point. All right, so there's so much wrong. But even, so then I could figure out what the inner radius is, right? And actually, I'm very specific here. What are A and B? Let's change these. 2 and 4, I like it. So what would the inner radius be? And the outer radius. Now, the minute I try to start figuring out the outer radius, what is wrong with how I'm given this? Considering, what do I need? I need everything in terms of, and this is currently in terms of, do you want to solve this for x? No. I don't want to either. Okay. It is possible, sort of. All right. So there's so many reasons to just give up on discs. And if that's the only method we had, we'd be done. And I know some of you guys are like, that would be fine with me, Jeff. Can't we just say we can't do this? Can't we just, no, it's too bad for you. So give up on discs. Move on. So what we got now is we developed, and I really want this to make sense. If I rotate this, aren't I, all my cross sections, how do I discover my cross sections for discs? Don't I discover them along this axis? Like here's a cross section right here. Don't I find that circle by where I am on the y-axis? That is why for discs, it's got to be dy. Now look at shells. How do I determine a rectangle that's going to rotate? Where's that rectangle located? On the x-axis. That's why it's allowed to be integral dx. So one of the most basic determinations to make about which method to use is if your function can only be in terms of one variable, then you know exactly which method to use, the one that allows you to integrate with respect to that variable. So this function can really only be in terms of x. That's all we want. We don't want to try to get in terms of y. So I need to use the method that allows me to do integral dx, which is shells. I like it. Is everybody with me? So there's a very clear motivation as to which method to use. Now sometimes both methods will work, and then then it could be one method leads to an integral you can't even do yet. Like, can somebody, well, I'm sure you could. This is a little bit evil question, but do you think you can do this right now? Does anyone have an idea of what that might be? Do you guys? What's integral of 1 over x? So if you're thinking the answer to this is 1 over x, you're thinking backwards, yes? So that's not what this is. Does anyone think we're able to do this right now? If you think so, teach me. Or because you already know a certain method, the very first method you learn in 280 would be what you would use here. But right now, we don't know how to do this thing at all. So if shells leads to this, then disks would lead to this. Do you guys understand? Because I would have to solve it in terms of y. Are you guys at all with me? So isn't this completely doable? Yes? So there are situations where both methods work, but one method has an integral that I cannot do. So then it's really clear which freaking method to use. And then sometimes both integrals work, in which case, who gives a shit which method to use, right? Okay, maybe. Okay. So here are the things with shells. So once you've determined you want to use shells, I highly recommend drawing in an example rectangle. It doesn't matter where it is. So I'm just going to put it here. It doesn't matter how fat it is, because of course we're going to let it get skinny eventually. How do I figure out where that stands? You said earlier. Say again? X. So where is this currently? And not this specific one, because it's just an arbitrary rectangle. Of course, it's at X. And again, the only time the radius won't be just X or just Y is if my axis of rotation is not one of the major axes, right? If my axis of rotation had been around X equals 1, what would my radius be now? No. X minus 1. This is so beautiful. The idea, big minus small. Yes, that's it. So if my radius had been 1, how far apart is it from 1 to x? X minus 1. That would have been my radius. Okay, maybe. So in a lot of respects, shells is kind of better, right? Doesn't square shit. The radius isn't as involved. There's never any inner and outer radius with it. It's kind of nice. Okay, so we've identified the radius is indeed x. What's the height? F of x, sure. So we're going to put, instead of writing all that shit, let's just say f of x. I like it. So all that shit's going to go here. And of course, what are a and b?
2 and 4.
Yeah. 2 to 4. I'm going to put 2 pi out here just because I can. It's constant, right? Radius is indeed x, and the height is indeed f of x. Oops, I'm thinking ahead.
Plug that into a calculator or just figure it out?
Excuse me? Is that an honest question?
What?
Okay, it was an honest question.
You can do it by hand. It'd be kind of rough.
No.
Yeah,
You will do it by hand. Of course you will.
Uh-huh.
Yes, of course. That is not rough. That's easy shit. That is easy shit. Why do I not care about 0.52? Why don't I give a shit about 0.5? Let's do one thing. Of course, what do I have to do right now first? Yeah, get the x in there, right? And Avi, hopefully you understand. I'm not like yelling at you or anything, right? Okay. I don't blame you. It looks terrible, but we're better than that. We're better than that. We're not scared about 0.52. What? How do I integrate x to the fourth? 1/5 x to the fifth. Whatever the shit that number is, I'm going to put it over 5. I mean, at the end, we're going to put this in the calculator, right? Are you with me? Okay. So then we get 2 pi times 0.52 over 5 x to the fifth minus 5/4 x to the fourth plus 14.9 over 3 x cubed minus 11 over 2 x squared from 2 to 4 and
Can you just multiply by x or not?
say again, sorry.
Oh,
I already multiplied by x. Now what am I doing?
So, if I integrated the inside first, I would have just multiplied by x. Wait.
Okay, now let me address this.
Okay.
I know exactly what you're about to say. I want to stop you. What is integration? Can somebody just give me like a quick, what is integration? Okay, I like it. Antiderivative. I would have also accepted area under a curve somewhere, right? The important thing right now is it's an antiderivative. Derivatives have product rule, chain rule, quotient rule, all this stuff, right? Integrals do not. They cannot. They can't. All right. So if I see something like x times 2x minus 1, that is not x squared over 2 times x squared minus x or something. Do you guys kind of see where that would come from? That is so desperately not, because if I took this dude's derivative, it's going to be a shitload more complicated than this. Yes? So integration does not have product rule, quotient rule, chain rule. It has answers to those. So what's the answer to chain rule? U sub. Yes? I don't know. Does that make sense? That's how I tried to teach it. In fact, I think that's the title of the worksheet I gave out. The answer to chain rule is U sub. So integration has to have processes that undo derivative rules. Yes? Okay, I really want this to make sense. Okay. Because I am seeing in the homework a few people doing stuff like this. But if you check it, will this derivative equal that? Only if you completely do the derivative wrong, yes, which is even more scary right now. Derivatives need to be our bread and butter right now, yes? All right, so that's shit. So, of course, I would distribute. And then I have pieces I can attack. Okay, I like it. All right, now, where is it? Oh. And what would I say right now? Does anyone know what I would say right now? I don't give a shit, right? I mean, and I really want you to understand. It's important to do the next step, but the next step's boring as shit, because the next step is plug a 4 in and plug a 2 in and subtract. Now, you got to do it correctly. So I would, in my calculator, I would plug a 4 in, I would plug a 2 in, and then I would subtract those two. Yes? Okay. Because I'm not going to make you do this by hand, obviously. I mean, that's kind of silly. So, yeah, honestly, I truly don't care. But take a second. Can you guys get the answer? And I guess I'm just going to accept your answer. Let me see. I'll do it in the legal way, and you guys do it the right way.
Would you distribute the 2 pi first?
I wouldn't.
Okay.
Yeah, I would figure out this at 4 and then multiply by 2 pi. You could even multiply by 2 pi kind of like at the end, where these f's are ignoring the 2 pi. Does that make sense?
Yeah.
Yeah. Oh shit. I've got statistics all over my calculator. Bum, 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 bum. There we go. Bum, 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 bum. Neato. Anybody got the answer yet? Almost? Yeah. 0.2 blah blah blah. I like it. So you should be able to get that.
Oh, you just plug in the graph.
How'd you do it, ABO?
I mean, not the vectors. I just put y equals and then plugged the integral we got, and then cheating.
How do you mean plug the integral you got?
Like I did F5 and then calculated the lower and upper bound.
So here's one way you could do this. So I got it
Yeah,
in
that's what I did.
y equals. Then I can change my table to ask. Go to my table,
Oh,
put
nice.
2 in, put 4 in.
What? Okay, wait, how'd you do that? I kind of remember.
Why did it? That's weird.
I think you got a different answer though.
Bum, bum, bum. 5/2, 5/4. Yeah, that's right. Okay.
No, minus
That's weird. Oops. Okay. I don't know why it's acting up right now. Huh. All right. Anyway, I know what I'm doing. No, this is true. Oh, I see what I did. Oh my God. Okay. So it shouldn't be 108.2. Now I understand what you did. So let's see. When I plug a 4 in, I get 102.81, right?
Oh, I know.
And when I plug a 2 in, you actually did the same thing I did, which is kind of funny. So you should get like 95 point or 96 point something.
96.1.
Yeah. Okay.
I know.
Now to check it, you could put this function in
Yeah.
and then do the integral function. Yeah. Okay. I like it. So we actually made the exact same mistake. I love it. So this is the kind of thing I want to see, right? But again, you can make the calculator do this for you, this piece, figure out the numbers, and then just take the difference. Okay, so I don't know. I know it kind of sucks that there's two methods and they are kind of different, obviously, right? So you have to memorize each separately, and then the next level would be how do you figure out which method to use? Shells, I always liked shells because for one thing, it's not squaring anything. When you square in disks, it really sucks. I mean, if your function would be this, and then you have to square it, maybe, yes? Do you guys agree with me? You want to square this thing? No. So that's one thing I always appreciated about Shell's method is it's not squared because of the way it's built. It's not squared. And I never have to worry about inner outer kind of radius stuff. It kind of just take. See how this has a big empty middle spot? Do you see how it doesn't give a shit? Because I'm going from 2 to 4. So am I even including like any rectangles from here to here? No, I'm not. It starts counting them at 2. So I don't have like a region I've got to subtract out. I have no idea if you guys are with me, but there will never be an outer inner radius for shells because it just kind of bypasses the area that's empty. Okay, so let's do this. Other side. Now, if I gave you this kind of problem on a test or a quiz or something, I would say give a rough sketch. Is anyone? Is anyone? Here, is anyone? What's the right word here? Screw it. Scared about trying to give a rough sketch of this? Can anyone else tell me why nobody else should be scared of this? Does this thing factor nicely?
Yeah.
Of course it does.
Oh, yeah, it does.
What method would he use to factor this? How many terms are there? 4. What method do we use? Grouping. I don't even know what triangle thing? All right, sorry, buddy. Ben's like, leave me alone. I'm giving it a try. Okay. So what comes out of these first 2? Even better? And of course, I'm left with x minus 5. All right, so I get y equals 1 minus x squared. Is that cool? Maybe? And of course, I get 1 minus x, 1 plus x, x minus 5. So I know this guy's x-intercepts. So where's this guy have x-intercepts?
5, -1, +1.
Yeah, 5, -1, and 1. What's the y-intercept? -5, yeah. And what's the multiplicity of each of these? So everything you were supposed to, and that might be a little harsher, everything you learned in pre-calculus is supposed to help you do a really quick rough sketch of something so then we can do work in calculus. Multiplicity is important. That's why I kept bringing it up earlier this semester. It's going to go through all of them. So in order to have a y-intercept here, it doesn't have to start up here so it can go through. If it started in here, it's screwed. All right, so it goes something like this. Through. So then what area are we talking about? Yeah, this right here. That's the only part that's in the first quadrant. All right. Is that like an acceptable pre-calculus answer to graph this function? No. Is it good enough for our problem? Shit, yes. So what am I rotating that region around? Y-axis. Okay. So take a second, don't say anything. Can you figure out what method would be better to use? And what you can do for yourself is, if you want to try disks, it would have to be integral d what? Y. If you want to use shells, it would be the other way. Now, which way? Same reasoning, yes, as we did just a minute ago. There's an obvious winner here. Which one? Shells, because I don't want to try to solve this for x. Screw you, disks. All right, go ahead and try to set up that integral. And for those of you thinking, I mean, there's really nothing wrong with putting it in the calculator to make sure your sketch looks good. But the people, it's very easy to tell when somebody didn't even try to sketch it on their own, because they're going to say it goes from 0.993 up to 5.007 or something, because they're tracing it on their calculator. That's shit. That's complete shit. So don't do that. All right, let's see. So we've got to figure out, so here's shells. Oh, get out of there. We do more generally. Okay. 2 pi is a constant. It can come out. It came from the idea of making a shell open, and then the circumference comes into play. That's why there's a pi in there. What's the radius going to be? If I draw in a representative rectangle.
X?
Yeah, the radius is going to be x, and of course the height's going to be f of x. All right, so this one's just a straightforward shell. I wanted to start with a straightforward one. Keep going. All right, guys, so we've known from the beginning this is going to go from 1 to 5, right? We identified the radius as x. We identified the height as the function itself. Arg. All right. So this should be the nice part, right? Sort of like word problems in algebra and pre-calc. Hard part was setting the shit up. Easy part should have been solving it. And of course, now we're at that infamous spot where, yeah, all the interesting stuff is done, right? Ah, crap. All right. Did we get that answer yet? No. I think it should be like 857.866. Is that right? And again, you could just put this in your calculator, do the calc integral from 1 to 5, and then multiply that by 2 pi, and that's the ultimate check. Let the calculator do the integration, right? Okay, maybe. Okay. Number 2, let's all agree on a method, and then I'm going to let you guys do this one on your own, basically. To figure out the method, what's the most important thing to look at?
What you can solve.
Yeah, okay, I like it. But what is the thing that determines, so I want to figure out integral dy or integral dx. The very first thing I look at to determine that is what my axis of rotation is. So it's the axis of rotation is parallel to No. It is y equals -2, which is parallel to
The x-axis.
x-axis.
Yeah.
So if I wanted to do discs, it would be integral dx. Shells would have to be dy. You guys with me? So discs and washers, those are the ones where the integral d thing is the same as what you're parallel to rotating around. That's nice. That's why I always start there, and then the shells is the opposite. So discs would be integral dx. So why do I want to use discs? Because it's already in terms of it's already in terms of x. Yes? Now, would it be really hard to solve those for x? No, not really. It would have a plus or minus part, so I kind of don't want to do that. But if I set up my integral and it's impossible to do, I'll have to go back and start over again. So sometimes that is part of the process. Again, this happens in a lot of mathematics. You do everything right, you get to a point, you're like, that's impossible. Then you got to go back and start over. Doesn't mean you made a mistake, it's just part of the process. So try to set that up. Now we know we're going to use discs. So I'm going to use discs so I can have an integral dx. Let's see if past Jeff made a good problem. I'm trying to remember. Let's see. Does this make sense? Yeah, I guess so. Okay, this should be okay. Yeah. very first few problems we did. So this is what I'm saying right there. See, I put like a little side word, intersections. So you need to figure out what's the intersections between those so you can identify what your region is. All right. So what does this mean over here, guys? This little note I put. What do I need to do? Because it's asking for the region between, so I need to know what that region is. So I need to know where these meet. Say again? Yes, exactly. Yes. So that was the first couple of problems we did, or at least two of the first three problems. I can't remember. So this should be really nice. Looks like past Jeff tried to be nice for once. Interesting. Of course, Jeff. Durr. Me, I'm smart. So I would go that one extra little step. You figure out where the x values of the intersections, what those values are. Then you go ahead and identify the points for yourself. So it almost doesn't, when I go to give myself a rough sketch, it only has to have certain things. All I care about in the rough sketch is show where they meet, what's on top, what's on the bottom. And these are crazy nice graphs, correct? So one parabola opening down, there's one parabola opening up. So obviously this guy's on top, this guy's down below. You can make sure about it though. So here's a little rough sketch. -2, 2, 7. So at 0, this is at 3. And at 0, this is at 11. So the bottom one is x squared plus 3. And the top one is 11 minus x squared. So that little UFO piece is what we're going to rotate. Does anybody understand if I wanted to rotate this region around the y-axis, would that be a problem? Yes.
Because it's already.
This is weird, but I figure I might as well bring it up now. It's already what? It's already kind of like, so if I rotate it fully, won't that rotation eventually start to go into itself? Okay. Yes, and indeed, past Jeff has created problems in the past where that happened, and I'm like, oh shit. But that basically doesn't really make sense because it sort of like burrows itself out again. It's a little, okay, so I try not to let that happen because it gets a little weird. But I am going around y equals -2. So that's down here. My scale is beautiful, and I don't care because it's just a rough sketch. So this happens a lot in cases where you have to set them equal to each other to figure out what the region is. The inner radius is going to be one function, and the outer radius is going to be the other function. That kind of makes sense. You guys see that? How do you draw in the inner radius? Where would you start? Yeah, from the axis of rotation. I love it. So that's the definition of radius. It starts at the axis of rotation, and it goes up. And the first wall I hit is the f function, and the second wall I hit is the g function. So what's r inner? Yeah, x squared plus 3. And what's r outer? 11 minus x squared. Become a square.
I thought our outer and our inner were only for the washer.
All right, so sometimes, all right, I do not agree. I think I've sort of said this before. I'm going to just say discs. Because what is a washer? What does washer method mean? Find a big disk, find a little disk inside of that, and then subtract. Yes? That's why there's an r outer minus r inner squares, right?
Yeah.
So it's washers. I'm sorry, it's discs. It's discs.
Just with a hole in the
Just washers has one more disk to figure out.
Okay.
So I just kind of refer to them all as discs.
Oh,
I'll do that sometimes if I'm not thinking to say washers.
it's confusing.
I know, but to me, I wish they wouldn't. It makes it sound as if it's a whole. No, it's the same shit. It's discs. You just have one more disc to worry about. Not a big deal. It's not like an entirely different thing. Yeah.
Are we taking the negative swings right now? Like the y equals negative swings? For the outer and inner?
Oh yeah. I'm being silly. Thank you so much. That's awesome. I was so focused on which wall was which. Of course, for both of these, here is what I've got written so far. And Nathan very politely said, Jeff, you're an idiot. What should that radius really be? Is it longer or shorter than this? It's yeah, so that should be plus 2. And of course, the same exact thing, it's plus 2, right? This is here. So then I have to add 2 because it's an off-axis radius. Yes?
How do you decide which function is the inner one and which one's the outer?
It really is exactly what I just said, and that's part of the reason why I'm not going to beat myself up too much about forgetting this, is I was desperately trying to say, to find your radii, start at your axis, and then the first wall you hit is inner.
Okay.
And then you do it, and you cross through that first wall, and then the second wall you hit is the outer. Okay. I was trying to make that point, and completely forgot about off-axis radius. Okay. But can you guys see, it makes sense I'm adding 2 because now I am further, I've made this longer than it would have been. So you can do these quick little checks when you write something down and go, does it make sense it's bigger? Yes, because now it's longer than it would have been if it would have just been the x-axis. Okay. So my r inner is actually x squared plus 5, and my r outer is 13 minus x squared. So now the disk method says, well, let me write it down as full glory. So the disk method says integral a to b pi r squared, and this is officially washer, but we'll be all right. So I want to take the difference between two disks, and in this case we identified dx. So that is the official thing. We're just doing disks twice and taking the difference. So now I can fill in everything I know. This is dx, so what is a and b? Negative 2 to 2. I can bring the pi outside. I need r outer squared minus r inner squared. This is the part that, to me, it's so cool. To students, it's frustrating and confusing. The integral I just wrote has nothing to do directly with the image we're looking at. Is this function there? No. This is the volume of something. Is this 3 dimensions? No. None of that matters. We've just written something that is equivalent to the volume of the rotation of this. Okay, really? Okay. I mean, real quick, I know, just real quick. What is the volume of a cube of side x? How many dimensions is this? 1. It just depends on x. Right? So we've written a volume, That is based on one dimension. Why? Because all the other dimensions are that size also. All right, this is a maybe a little stretch, but not really. I mean, if I had a box that was this, what is that volume? XYZ. Can you see all three dimensions? Yes.
Isn't that just three dimensions of the same thing?
Yes. So when I write down the expression, can't I draw this? Wouldn't this function be, let's not go to 0, but wouldn't this be cubic? Right? It would be like this. Beep, 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 beep. Yes?
Yeah.
Does this image have anything to do with the cube itself? No. It's a two-dimensional image I've just drawn, yes? All right, maybe I'm going too far. I really just want to show you, we've done this kind of thing before. We just didn't really realize that specifically, that what we were working with didn't necessarily look like it was three-dimensional. So now we're just doing the same thing. It's just a little more in our face because we have to be more concerned about details. Anyway, I've gone way past that. I should have talked about it. So let's see. How do I do this? I have to foil this stuff out. That's going to be exciting. Uh-oh. Somebody already.
When do we square? Like, why do we square?
Say it? What?
Oh, it's outside. What?
What do you have to do with the radii, of course?
Oh.
Because the whole idea of a disk
Yeah.
is adding up areas, and areas of circles are pi r squared. But I understand that's one of the easiest mistakes to make is to forget this, especially if your brain goes, it's already squared. But no, it's not. Minus x to the fourth minus 10x squared minus 25. I think that's all good. And then we've entered the Jeff doesn't really care zone here, but I really hope you guys understand it. Negative 2 to 2, pi out front, 144 minus 36x squared. And the x4s die. That's nice. Die. Okay. Very sorry about that. Just celebrate those kind of things. That's nice. Look at that. That's a lot better than we feared. Yes? So then we get pi times. Right, everybody should be able to do this, right?
Yeah.
What's this become? Yeah, I'm just going to suck a 3 out of this.
Well, that's cute.
Yeah. From negative 2 to 2.
Can we move the page back down?
Say again?
Can I see what you wrote before that?
Oh. Another easy place to make a mistake is to figure that negative's got to go through the whole thing, right? Right here? Yeah. Negatives find a way to screw us over. And then whatever the shit this is. I don't care. 288 minus 96, is that what that is? Some of you guys might realize you just have to plug a 2 in and then double it because this is an odd function. All right. So I think it's 288 minus 96. Is that right? 200 minus. So 192 is that 384 pi? Is that what that is? I think. So like 1,000 something if you multiply by pi. I think. Okay. All right. Woo! So that's the most boring step because it's plugging an old calculator. Whoop-de-doo. All right. I wanna do something. I don't think this last problem does what I want it to. Let me think about it for a second. No, it doesn't do what I want it to. All right. I'm gonna go off script here. And yes, I have a script. There's a little dude right here with cue cards. I want to redo number 2 because it was so fun. Let me think. Is this going to be weird? Yeah, it's going to be weird, Jeff, but... Oh, yeah, that'll work. Okay. So we're not doing number 3 yet. We're going to redo number 2. I'm going to make one change. So I want to find the volume, rotating these two about x equals -2. So that's the only change I'm making. So instead of rotating around something parallel to the x-axis, I want to rotate around something parallel to the y. So it's going to look like, so we still have all the same stuff. It's still -2 and 2. It's still 7. Let me graph this thing. I don't know. So it's something like shua and shua. Okay. Looks like it's looking at me. All right. So now our axis of rotation is x equals -2. So if I want to use disks, what would it have to be? Integral d what?
dy.
So do I want to use disks?
No.
Not necessarily.
You do shells?
It's more doable than earlier ones, but let's see if shells would. Shells would be obviously dx, which has the added bonus of I don't have to solve for x, right? So can somebody, so here's where things get nifty. All right. This is why I want to do this one. Let's see if you guys get this. So I'm going to find, so where is my rectangle? If I'm going to draw in a rectangle, it's got to be in the region I'm rotating. So for example, if I just pick an arbitrary place and I draw in a rectangle, there it is. And then I would rotate it around. Obviously, it's not including this little bit here, right? Because that's empty. So how tall is that rectangle now? So the radius, well, let's see. What do you guys think the radius is? I like it. Two separate answers at the same time. Oh. So here's x, right? Which one's bigger, x or where this is? X. How do I find the distance? That minus that. So x minus -2 is x plus 2. Yes? And again, watch this. You can check yourself. Check yourself. So if x is 2, what should the radius be?
4.
4. 2 plus 2 is 4.
Yeah.
If x is -0.5, what should the radius be?
1.5.
1.5. -0.5 plus 2, 1.5. So just take a quick second and just physically check it. Because it's so stupid easy to make a mistake with the radius. Write something, pick a couple things, check it. Yes? Because if you get the radius wrong, you're screwed. Okay. Now I'm still going to give you partial credit. Don't freak out. But you ain't never going to get the right answer, but you'll get something maybe if everything else is okay. What's the height of that rectangle? No.
G minus F.
There it is. What's on top? G. What's on the bottom? F. So the height is going to be G minus F. Isn't that just like section 6.1? Top minus bottom to figure out the region. Okay. So the height here would be 11 minus x squared minus x squared minus 3. So the height would be 8 minus 2x squared. Which, of course, is related to the work we did earlier to figure out where they meet, yes? How you guys feeling so far? Say again? What about what 2?
Are we adding the 2 in yet or not at all?
Okay. No, all right. Where did we add the 2? Here. To the radii, correct?
Yeah.
Didn't we already take care of that?
Oh, right.
The height doesn't give a shit about, right? These rectangles, do they care where the radius is? If I put the radius here, I would still draw the same rectangle. Yes? Okay, good. Yes?
So it would be 2 pi x plus 2.
Well, let's see. Okay, so shells requires 2 pi integral. It needs the radius, it needs the height, and we've already determined it's dx, a to b. So it's going to be 2 pi. Since it's dx, it's going to be from what to what?
From negative 2 to positive 2.
Negative 2 to 2. Radius is x plus 2.
Okay, yeah.
And the height is there. So I don't know why this is, but I always felt like shells just made more physical sense. It might just be me, but I always felt like I could find stuff a little bit easier. I don't know. Thinking back to when I was a student, now it's like the same shit, but when I was first learning this, I got shells a little better. Of course, I think I already told you guys, I didn't understand this at all when I first learned it because the teacher really didn't lay anything out. It's just like, here's what you do in this case, and here's what you do in that case, and here's some examples, and leave me alone. I'm like, oh shit. Now I've got my integral set up. Did I forget anything? Let's see. No. Okay. This is relatively nice, right? What do I do to do this? Yeah, FOIList stuff. Let's see. Same thing. No. So we get 8x plus 16 minus 2x cubed minus 4x squared. All right. Not bad at all. 2 pi. Oh, I guess I can enter. There's no like terms, Jeff. 4x squared plus 16x minus 1/2 x to the 4th minus 4/3 x cubed from negative 2 to 2, and then who cares? Okay.
So you would do f of v minus f of a and then multiply by the 2 pi, right?
Yeah, you plug a 2 in. Yeah, I would do that. I would be 2 pi, figure out what that is, figure out what this is.
Okay.
So you can multiply by 2 pi at the end, yeah.
Okay.
In that integral, can you take out a 2, like, you got a 2 and just times that by 2 pi, so it's like 4 pi?
Yeah, totally.
Okay.
Yeah, you can totally take a 2 out. I guess it doesn't, well, it would make this, it wouldn't really make anything too much worse.
Yeah.
Took a 2 out, but yeah, you could. Yeah, of course. You can always take a constant out.
How do I check that on my calculator?
2 ways. To get these, you could put this function in, and then in your table you can tell it 2 and negative 2 and get the numbers. Or you put this into y1 and you tell it, and include this, right? Include that, put that whole thing into y1, then do calc number 7, integrate from negative 2 to 2, yes? So like, real quick. So I could put in there 2 pi times 8x plus 16 minus 2x cubed minus 4x squared. Graph. And then second, it's still thinking. Okay. Second calc number 7 for integrate from negative 2 to 2. Kabam! 268. Is that all right?
Yeah.
There might have been some glare in there. I'm sorry. Or, I mean, that's how you check after you've done everything. To get these values, you put in, oh God, Oh, screw it. I'm not going to do it. You put this in, and then you could do the table where you tell it 2 and negative 2. You can get what these values are. Just, it's quicker than rewriting this whole thing with the 2 in it and rewriting this whole thing with the negative 2 in it. But you could do that too, right? Okay. You just have a real issue if your volume comes out negative. This is different from just a straight up integral. It could have negative area if it's below, because that means you're losing an amount. That makes sense. This is supposed to be a physical volume. That's the difference. These problems are actual physical volumes. We really shouldn't have a negative. Okay. Are there situations where negative volume makes sense? Yeah. When they don't represent an actual physical shape. Okay. Okay, maybe.
Did we get the answer yet, or no?
Yes, we did. I forgot what it was. It was 208 something, I think, maybe? Is that right? 268? Okay. Ruh-roh. Okay. Let's see what time we got. Let's call it a day, guys. We'll do number 3 next time. Next time, of course, being a week from Monday. Take next week off. We got a quiz on Monday, 5-3 to 6-1.
That's just a quiz?
Say again?
That's just a quiz? I thought it was a test.
No, when's the next test?
December 2nd.
Third. Yeah. Let's make it on a Friday.
Okay.
Yeah. All right, so enjoy your Thanksgiving week. Don't get too used to it. I don't know if they're going to make that a permanent thing.